Alrighty then. So in about mid to late 2020, having built my EV-2 and having fairly much fine-tuned it and got it as a successfully working printer that I use quite frequently now, I noticed that I had a lot of spare parts lying around. For example, aluminum profile. I had a smaller heated bed from an earlier experiment in building a printer, and various other parts. And I thought to myself, well, why don't I build another printer? Now, I didn't want to go hardcore and build another enclosed CoreXY. I had, as part of the spare parts that I had, included parts for an i3 style, sort of old-fashioned with the linear rods. And so I thought, oh, I'll just make a essentially a Mark II, Prusa Mark II type of clone, which I think was actually the first printer I built was a clone of the Mark II S. But I thought, well, I've got these spare parts, and what I really wanted to do with this i3 style printer is have a very similar ecosystem to the EV-2, specifically use of a enclosed electronics case and the big Tech TFT, 24 volt power supply, E3D V6 hot end, which is relatively cheap, especially the clones, and I'm quite familiar with it. So I set about designing this printer in Fusion 360, ordered a few spare parts, and the video I'm about to show is the result of my thoughts and design process in making the EV-3 and finally printing a nice little 3D Benchy. So I thought I'd go over how I fine-tune the lengths of the aluminum profile. Now, because I just have an old drop saw and I can't get very good accuracy with it, probably the blade needs replacing, but it's just something I can't justify at the moment paying the money for it. So I roughly cut the ends, and I basically have this thing that's I call it the index piece. So this is the exact length I want it, which is 350mm. And I set up the set square here and just clamp it in place on the bench so that I have a square 90-degree angle. And then my index piece I put like so, nice and firm against the surface there. So when I line up the piece I'm checking the size of, I then hold them together so that they're butted up against the edge, obviously, and I just run my finger over the gap between them, and when the gap is smooth and there's no ridge, I know that they're the same size. So if they're not the same size, I then come over to my disc and belt sander, and this is set up for a 90-degree angle, and I sand it once, rotate, well, I sand it briefly and keep rotating it so that I get a uniformity of a 90-degree angle based on the angle of the bed here and the square here. And I do that a couple of times, and then I just return back and repeat the process. This one is good. This one here is bad. Unfortunately, I overcooked that one. But that happens, it doesn't matter. I've got plenty of these aluminum profiles left, and it's going to be a length for something else. So these four aluminum profiles, 2020 aluminum profiles, are my base frame for the EV-3, and I was going to actually use these brackets here, but I thought, well, why don't I just go with the larger brackets that have two mounting holes, because it's simply going to make the frame more rigid. And since this is the base frame of a i3 style printer, might as well use them. There's no reason for me not to use them. Yes, it requires double the amounts of bolts and the double the amounts of T-slot nuts, but I get a more rigid frame. And incidentally, these holes are 4mm holes, and I've moved away from using 3mm on the 3mm T-slots, or even anything to do with mounting something on 2020 or 2040 profile. I've moved away from 3mm to 4mm. It's just a much more robust solution, and parts are easier to print too if you have a larger hole, obviously. I implemented a belt tensioning system using some flat sheet metal that I bent into a C-shape with straight edges, and here I'm using a nail punch to make a divot so that I can more accurately drill the hole, which will be eventually for the pulley shaft. And here is the end result without the pulley in place. I'm using a 3mm threaded bolt held in place with a nylon lock nut. And to perform the actual tensioning, I used these wheels that came from a spring system for a heated bed. This picture here is showing it on the x-axis. So I'm putting together the base frame here, and similar to the way I actually precisely measured or as precise as I could measure the length of the aluminum profiles, I'm using a similar technique to actually make sure that the ends of the brackets are nice and flush in terms of the aluminum profile butting against each other, and also at a 90-degree angle. And so I've just clamped down the set square. I've clamped the bottom piece here, so nothing moves here. The only thing that's going to move is this piece, and then obviously position it flush against the set square, and then slowly tighten it up. Slowly tighten up the bracket parts. How I actually drilled these with my drill press was using these 3D printed jigs, and so this jig here is just for the bolt hole, which I, through just experimentation, I figured out which one was the right bolt hole, as I talked about earlier. And this jig here is for the countersink hole, so it's a lot larger. That's the difference. And of course the countersink hole has to match the size of that head. Now I did this on the EV2, and I started to do this on the EV2, and in the end I gave up because I think one of the reasons was the precision of the drilling. You just couldn't get it perfect enough or precise enough, and I found that the angle brackets worked just as well. But having said that, well, at least the angle brackets enable you to really precisely position things and then tighten them up in place, whereby you had to rely on the precision of the bolt holes that you drilled for the frame alignment. Now, this is an i3 frame, so it's slightly different, and I'm hoping that I can get away with the way I've drilled these holes. Now, someone with some better equipment would be able to more precisely drill these holes. I unfortunately don't have that better equipment. I just have an old drill press, and therefore I use these. I don't have a milling machine or anything that I can be really precise about. So I use these 3D printed jigs. As essentially, you can see that's a raised area, and the guide hole, I used the wall of the drill bit to guide it into the hole, and then I just press down on the part to make sure it stays in place as I drill through the profile. I think I've introduced this before. It's a fairly effective method when you don't have precision drilling equipment, but it doesn't always work. So here I'm tapping this 6mm, around 6mm hole for attaching. These are the Z-axis, so I have to do both ends. One obviously for the top bar where the filament reel goes, and also for the bottom to attach to the frame. So what I've actually done first is I've just drilled a slightly larger hole in the existing hole. If I just grab my little jig, so I'll use that at the end, and it's about 12mm of space there to help me guide in drilling out this hole. So it's just so that the when I make the thread, or tap the thread, that I don't put too much strain on the actual on the bit itself or on the material. So it's a relatively easy process. So here's the end result for the, I guess the Z-axis frame. Really happy with the results. Ended up being nice and flush, and just having that a little bit of slack in the bolt sizes mean I can actually position it precisely and then tighten them up. So I'm really happy with that. The only downside was that the heads of these bolts protrude out a bit. It would be nice if they were flush, but it's just that the heads, okay, look at the edge there. You can see the heads are a bit too large for, I guess, the float of the aluminum profile, but it doesn't matter. So I just thought I'd show how, as I'm putting the extruder body onto the stepper motor here, and I have the holes here for the springs, for the idler spring that attach, with the bolts attached to the nut embedded inside there, so that flexes back and forth. As you can see, there's the idler wheel in there, and this is the actual setup that I use. So I 3D printed these shims that go on either side of the spring, and essentially they're long enough to provide good enough surface area so that there's not too much friction in that hole, so that they slide back and forth, and obviously the shim itself is wide. It isn't a tight fit, so it needs to be a loose fit. So I'll but before I actually put these inside, I'll just use some Vaseline here just to make sure that the entire, I guess, the tunnel or the hole in there is not going to bind up. And the other thing worth noting, which you can't really see from there, is I'm using these bolts that don't have a thread across the entire length. So the area where the spring, well, most of where the spring is and where the shim is, or shims are, is smooth, so it's less likely to bind up. If it was like thread all the way the length, there might be some binding up on the actual thread part. So that's, yeah. These happen to be black, just the ones I've got with just, well, anodized, I guess, yeah. Okay, so there's my Z-axis ready to fit, and there is the bed with the frame, and as you can see, what I've done is I've perfectly centered the bed in relation to the ends of the frame, and then taped it down so it won't move, and in the middle I've drawn this line so that I can then mount the frame on top and get the nozzle, the point of the nozzle, perfectly in the middle, so I know exactly where to position the Z-axis for drilling. Now I did measure this in Fusion 360 when I designed it, but this is something I don't want to get wrong. So this is essentially double checking and confirming my measurement. Otherwise, you know, once I've drilled the holes, I can't undrill them. And so I've just positioned the Z-axis frame and lined up the nozzle with the middle center line. And I'm simply just going to take my ruler and measure from the frame to the end on either side until such time as it's level, and I can take that measurement and know where to position the jig for drilling the holes. Alrighty then, so now I have the Z-axis frame in place. You can see there's the mounting bolts there. Sorry, the light here isn't that fantastic. It's because it's the other side of the window, but anyway, and is the other side of the mounting bolts, and those are nice and flush. But instead of worrying about the squareness of the frame, really the important thing is the squareness of the nozzle as it travels along the x-axis in relation to the bed, so that if you do have any inconsistencies in your frame squareness, it doesn't, you want to compensate for that where it matters, which is in the nozzle travelling along the bed. So I've just used these closed pegs to keep the bed basically in the middle, and then I haven't got the threaded rods in place, so this is just smooth travel, and for the time being I've secured one end, but this end is not secure. And what I'll do is position a nozzle above the bed and just move it over manually and see what sort of change in distance I get, and then move this either direction so that I get a relatively parallel movement of the nozzle compared to the bed. Once that's done, I'll secure that in place, that end in place, and now I know I have my basis for positioning the other side. So I'm just sort of measuring out the walls for the electronics case that will sit below this frame, and this material here is 4.8mm MDF, the same material that I used on the EV-2. I would love to use some sheet metal, some thick sheet metal, as a lot of the professional 3D printers use, but that's just cost prohibitive to me. So once this is painted up, I think this will do fine. So this is the, I guess the base frame, the frame base sheet that's going to go underneath here, so that you won't see the electronics underneath. And I just measured out all the holes that I need for the wiring. So these holes on either side are for the, here, the Z-axis, and for the x-axis and the extruder wiring, etc., and that one's for the y-axis motor, and also measured out the holes for securing the this base, this MDF, to the frame itself. So I finished the framing for the electronics enclosure. Obviously there's that top part, that I had pre-painted before realising I needed to put more holes in it, and so I've ended up just putting everything together, which is the way it should have been in the first place. There's obviously the hole for the LCD panel, and on the side there I've got the fan, which will be blowing air over the motherboard and then out the other side. So one will just be for the fan, and the other one will just be a fan guard for the air to travel through to get a nice cool air flowing through the case. There's obviously the IEC power connector, which will be screwed into there. So the power will come in through here to the power supply that will sit there, and there's obviously the holes for the stepper motors, etc., which will all be connected to here. And then the LCD panel will connect to the motherboard. So as you can see, I've made a lot of progress on the electronics enclosure. It's now attached to the printer itself. So this printer, you see the frame there, it's upside down, resting on these two sawhorses, so that I could push the enclosure onto it. And I've added the IEC switch. There's the wiring with the switch going through the live, and obviously we've got the grounding here. It's all hooked up. and I have a total of 4 24 volt outputs. One of these is doubled up, and that's just as a spare, which is the same way I did the EV-2. I think the spare is used for a fan, if I remember correctly. Obviously we now have this bolted in place, the meanwhile 24 volt power supply in place. I have these 3D printed standoffs which the lid sits on, and also at the corners, hence why we have these large holes here, which are not only for the bolt heads, the 4mm bolt heads, but also so that we can have the bolts of our feet, our rubberized feet, on each corner. Yeah, I'll have them on, as I said, on each corner of the lid, but I just repeated the pattern on the other standoffs, which, as you can see, also have the 3mm hole, and I've inserted the square nuts in there and put a little bit of hot glue on them so that the square nuts don't come out. So it's late at night, and I made a lot of progress. As you can see, the printer is assembled and working. The screen is working. Same interface. I'm trying to keep my shadow out here. Same interface as the EV-2. Same blue colour. I've just loaded some white PLA. I've lubed up all the rails and the bearings. I've got my removable bed sheet on there. So here's my first test print of a Benchy. This is in white, so the detail is not too bad. 4mm nozzle. I can't really complain about that actually.